Okay, today we are making a bridge out of wood, but not just any old bridge. We are going to be making the Florida International University Bridge, which collapsed several years ago. Let me just grab something. Okay, so I've got a video planned in the next few weeks or so that looks into detail as to why this particular bridge collapsed. As you know, it's planned. I've got 10,000 words in the script that I'm trying to finesse. But as part of that script, I either need some B-roll footage or I need a prop that I can play around with and manipulate to demonstrate some of the principles that I'm discussing in that video. And it's probably going to be more of the second part of that than the first part. There's not an awful lot of times, 10,000 words, but there's an awful lot of stuff I need to refer to on the screen. I don't know how much B-roll footage I'm going to need. So I think probably what I'm actually going to do is have a prop that I use in that video, and then in this video I'll film and demonstrate how I'm going to make this bridge, because it's quite a cool thing. It's a very unusual geometry, and I think it would be a nice thing to have to demonstrate in that video. So what I'm going to do, this is a drawing that has come about as part of my research. You know, I say it's research, but really all I've done is there's a single website on the US government website which has looked into the bridge collapse, and it's a resource for everything that you might ever need if you're looking into this bridge. So they've got the drawings. I found the drawing. This is that bridge. I mean, if you want to imagine, this chunk actually exists over here, over on this side of the map, on this side of the page. You know, they couldn't fit the whole bridge on the page without making it really, really small. So that's the bridge that we're going to be doing today. But I have a slight thought process that I want to explore first, and I really want to explore that geometry, that idea, which is the geometry of the bridge itself, and then explain why I've explored it. So what I've done is I've taken this drawing and I've Tipp-X'd everything out that's not important, and we end up with a drawing like this, which is just the basic geometry of the bridge. And I'm going to mark up on here with some felt tip pens the thing that I want to just explore just for a moment. So let me just do that quickly. So there are a lot of fundamental problems with this bridge, fundamental engineering problems, and I explore a lot of that in the main video that I'm working on. But what I didn't get a chance to explore was the detail of it, how it fitted together. You know, there's kind of two stages to this process. There's the engineering of it, there's the design and the analysis, and then once you've got all of the design and analysis done, then you actually have to make the thing. And in the engineering world, we always model it as if things are perfect. That we set out with the idea of things being perfect. But then when it comes to detailing the thing, sometimes that perfect model can get skewed just a little bit. Not a lot, but just a little bit. And it's always indicative to me how close to the perfect model these things get to. And this is what I wanted to demonstrate with this plan. What I've drawn on here are the center lines of all of the members in this truss. And in an ideal world, in a perfect world, we want all of these intersections to join up in a single point, a single node in the engineering speak. And for the most part, you know, the bottom chord all coalesces in a single point. These are all good. These are all what we're looking for when we're trying to create that alignment between the perfect engineering and the perfect detailing, because that's what this is. This is the detail of the structure. There's the design, the analysis of the structure, and then there's the detail and how you fit it together. If we look at the top chord, however, there seems to be this kind of little triangle that exists. So what's actually happening in this detail, this member is in compression, so we've got a force exerting itself in this direction. Now this member, because it's in a funny angle, we're just going to assume that it's in tension, but we can't really be sure of that because it's a funny angle. But the point is that that's exerting itself downwards. This is exerting itself this way. And in the deck itself, we've got compression, which is acting itself like this on the junction. But these two lines do not coalesce with the point that's here. We have this kind of little triangle. And what that actually is a slight out of balance load. Now, in real world terms, it's not a problem because we've got this massive member. You know, we've got these massive members, and all of these points exist within these members. So the fact that it's not quite central is not a big engineering deal. You know, that's kind of part of that's part of what happens, to be honest. You know, you have to work around things. And these guys were post-tensioning, sorry. They were post-tensioning a lot of this stuff. And this, what we have here is the main structural deck. This is the main structure that's doing the work in the bridge. And then we have this kind of bit that sticks up at the top. And I'm guessing that this is specifically for the post-tensioning part. So that's not really structural. This is just kind of dead concrete that's part of the detail of the structure. What I really care about is this part of the decking. That's the bit that's doing the job. So from a perfect engineering world, it's not quite perfect. You know, it's not quite what I would have wanted. It's a little bit different. And that's a consequence of the design of the bridge. Is it a problem? No, but I just like to look at it to see, because that's where they would have started. They would have started out with this perfect, and then they would have had to move it around and adjust it in order to get everything else to work in the same thing. But from my perspective, I suppose the geometry of this isn't too bad. In my mind, I was kind of expecting some of these joints to be particularly bad, and I was going to have to try and manhandle them into a perfect geometry that I could actually craft in my workshop, because there are fundamental limitations to what can and can't be done with the tools that I have, and some of this stuff might not necessarily have been possible. But I think I can do this. I don't think this is too bad. It's better than I thought it was going to be. So what I'm going to do from here, I'm going to start completely from scratch, and I'm going to just plan out all of the members that I need so that I can start planning the geometry of the bridge that I'm actually going to make. Yeah, that's what I want to do. So I think that's how I'm going to approach the thing. I've obviously got some main structural members here. Let's do it with a pencil so I can rub it out. Main structural member here, I can do that. And the end pieces, nice vertical angles, I can deal with that. These slight angle ones, these are going to be easy. I've got a saw that I can do that nice and easy. Probably this one as well. This one, this one, this one, this one, and this one are all going to be difficult in some way or another. I might have to end up with like some kind of corner piece that goes in the corner here in order to be able to cut a piece that goes in there. Even that's going to be difficult though. I'm fundamentally limited by what I can do in the workshop. But anyway, that's enough, more than enough talking. Let's get down there, let's start cutting up some wood. Alright, so we've got all our main pieces sorted now. We've got a chord member. These have actually worked out a lot smaller than I thought. And this is the bigger one. There's a smaller one as well. If we put them next to each other, I suppose that's probably the best way of doing it. So because there's some slightly bigger members in the truss, which I'm going to use this slightly thicker plywood for, and then for the other members I'm going to use this thinner one. And then we've got, it's probably difficult to get into shot, we've got the top chord and then the bottom chord down here. So what I just need to do is I need to start cutting it up all the right shapes and sizes. And I thought about working out all the individual angles, you know, doing everything, sitting down for an hour or so. But actually what I need to do is I need to plot out each, as I do it, one member at a time. That's what I'm going to do. I'm going to do is I'm attach the top and the bottom with these side pieces, so I've got a frame, and then I'm going to individually place these parts in as I make them. That's the plan. Let's see how it goes. So this is what I'm worried about. As I'm building it, obviously in the final state of the bridge, it will be quite strong with all these chords. But while I'm building it, it's not going to have any strength at all. You know, these things are tiny. You know, we just kind of balance it on top. It's got no real kind of rotational strength for stability. I know I'm going to glue it and screw it, and that's going to give it something. But, you know, for a long time it's going to be very weak. It could pancake, it could do all sorts. So what I think I'm going to do is I'm going to construct like a cocoon, a frame around the outside of the bridge to hold it all together while I construct it. You know, it's not just about strength. The thing could all fall apart, yes, but also this is bendy. You know, I'm going to be relying on this for its geometry. So if this was bent or out of place, then the chord's going to be slightly out of place. I'm going to end up with a bridge that's slightly crooked. So I need a frame. I need a frame around the outside to hold it all together so that it's in the right shape while I fix it together. That's the plan. Okay. So I need some of those. Okay, we have our bridge in the middle, just about, you can probably see it, squeezed in the middle, And then we've got these big bracing bits to clamp it all together. This isn't going anywhere, it's all solidly in there now. These pieces are just here to stop the thing from twisting around. I can take these out and move them whenever I need to. They're just to give something there in there, so it doesn't have no strength at all. And from now, what we need to do, we need to make all the chords. This is the bit that I was worrying about. Should be a bit of fun. Okay, so that's the first lot of chords done, or at least the easy ones, you know. These are the straightforward ones. Now I have to do all the diagonal ones, the ones that intersect with all of these ones. And if you're wondering how I kind of working out the geometry of all of these things, before I started making it, before I started putting it together, I marked up all of the joints where the chords were going to join each of the top and bottom chords in felt tip pen, so that I couldn't rub it out or sand it down or anything, so I couldn't lose them. It's not perfect, but you know, in this workshop we're dealing with plus or minus a millimetre or so, so if I can get it within that sort of rough mark, then I'm happy. Anyway, let's do some complicated ones. And we have our bridge. It's actually quite nice. It's very pleasing. The geometry is quite nice. Now there's a few things that I still need to do. Firstly, I want to sand it down. There's some remnants of a bit of glue and pencil marks, and I just want to just detail it a little bit. Then I want to varnish it. Before both of those things, I want to put it under some load. I want to put it under some stress to see how it reacts. But before I can do that, I want to strengthen it a little bit. These corners here, these four corners of the top chord, I really don't like them. It just feels like it's way too unstable. So what I want to do is I want to put a little piece, a little strut underneath each of these corners, just to give it some kind of strength and rigidity. You know, I'm not sure whether that's something that they actually put on the bridge, but it is something that I'm going to do because, you know, if I want to make this like a display item or something, it's got to stand the test of time. And I think it will be much stronger with those four pieces in. So that's what I'm going to just quickly do. It shouldn't take too long. And then I'm going to put it under some load and see how it does. Sweet. Alright, we have our bridge with our vertical props. And I'm just going to put some load on it. I just want to see how it reacts. Now I've got some weights here. Just going to add them incrementally. So 2.5 kilos. Okay. Another 2.5 kilos. Alright. One more. Oh, wow. I didn't expect it to actually do it. Let me grab another one. I don't like this. This is heavy. This is 10 kilos in total. Okay. Let me just watch back the footage and see how much it moved. What happens if I move it up? Oh, it doesn't feel like it moved at all, deflected at all. Let me just have a look at the footage. So that was a little bit unexpected. I thought it would move, but it doesn't look like it's moving at all. I think what we've got is just a very, very stiff bridge. But I think if I loaded it up with enough to make it move and deflect the way I wanted it to, then it's going to break. You know, I didn't think it would get anywhere close to 10 kilos. But anyway, I think it will serve my purposes. Can I induce some torsion? Oh, not without breaking it. This is a lot more fragile than I thought. Okay, I need to rethink. Let's do some sanding while I have a think about what I'm going to do with this. Turns out I broke it a bit when I was trying to do that torsional thing. So now I've got a clamp re-gluing it. Which is a sucks because I wanted to get this finished today. It's kind of holding me back a little bit. But where I want to go now is I want to sand it and I want to varnish it. But neither of those things are going to be very interesting. So let's just leave it at that. You know, a nice little failure just to bring the video to an end. God damn it. But next time you'll see this, hopefully it'll be nice finished and varnished in a much more detailed video. A much more comprehensive look at this bridge. Because it's an interesting thing. So we'll see you there, hopefully.